Welcome, this is Black Lotus, your YouTube script kiddie, and today I will be performing part 1 of 2 for a basic classification model. In this part, I will be actually training the models and selecting my model, and in part 2, I will be making a GUI application for this model. The data I chose for this classification is from the UCI machine learning repository. It's the shuttle dataset. In this dataset, there are not any missing values, and there are 9 attributes and 1 target feature. The dataset is imbalanced, and so just guessing the most frequent value should yield approximately 80% to belonging to one of the classes, and the aim here is to get at least 99 to 99.9% accuracy. I'll also be checking precision, recall, and my F1 score to make sure that I'm on the right track. I've already downloaded the dataset. It comes in both a training and testing set, so I do not need to split that out from my data. And just going to get started right now. So the first thing I want to do is create a dummy classifier and set up the number of cores I want to use for some of my algorithms. So up here, I'll create a global variable called cores, and I will set that equal to 1/4 of my CPU count. And feel free to use as many cores as you want for your models, more or less. And down here, I'll go ahead and specify a train and a test variable. And my train variable will, or my train path is in the same directory, so I will call it to go to the shuttle data directory and the shuttle train file. And these are CSVs. Okay. And it should be shuttle underscore. And for some of these models, I'm going to need a random state for reproducibility. So I will specify a random state for the variables for this one. I'll just choose 1000. And I know the separator for this data set is in fact a space. And one other thing I will also need to know is that there aren't any headers for the training and testing data. So I'm going to create 2 data frames, one for my training set. So I will call pd.readCSV and put in my train, the separator, and specify that there are no headers. And I'll create a data frame for my test variable as well. pd.read, CSV, test, sep, and then header. Okay. And the next thing I need to do is to tell my my program which are the attributes and which one is the target feature. So for my X train, Y train, I will specify that they are for my data frame consisting of all the rows and all but the last column. The last column is where my feature variable will is for both the training and testing set. So I will do that do the same for my Y train, except I will specify that I want the last column. And for my X test and Y test, I will do the same, except I will specify that I want my data frame test. So all rows and all the columns except for the last one. And then for my Y test, I want all rows and the last column. And this one's going to be df test.ilog. Okay. And let's make a dummy classifier. So just to make sure that we're on track, and I'll say dummy model is equal to dummy classifier. The strategy I would like will be the most frequent. So by default, it's the prior, but I prefer most frequent. and it won't matter. The random state for the dummy classifier won't matter because most frequents should always yield the same results. However, for best practices, I will, in fact, pass in a random state. Random state. Okay. And for my dummy classifier, I need to fit it on the Y train, or X train, Y train. And then I can print out the score. So dummy model.score, X test, Y test. And the website said I should yield approximately 80%. So let's take a look. We'll open up the REPL, save this, open up my IPython REPL, run shuttle.py, and I do get approximately 80%, 79.16%. Okay, so I'm on the right track. Okay, so I want to be able to do that, but for several models. So just so I don't keep repeating myself, I'll go up here, and I'll define a function called train model. And in this function, I want to take in an algorithm, and X train, a Y. I want X train, a Y train, an X test, and a Y test. And I want to return that algorithm with it fitted on the X train and Y train. And the X test and Y test are simply for wrapping purposes when I want to check my square metric. So I'll give them default variables as none. You can choose to keep these or remove these if you do not want to create a wrapper. I'm going to create a wrapper just to make my life easier. Feel free to do it as you wish. Get rid of these. And let's make the wrapper. So we'll call this wrapper basic stats classifier. And I'll take in since it'll be a wrapper function or a decorator function, pass it in a function, and then define an inner function, passing it the arguments. Okay, and for this, I want to make sure that my variables are in fact local variables. I don't want to use any of the global variables. So I'll go ahead and say, well, let's separate args first. How about that? So X train, Y train, X test, and Y test will be equal to my args. Okay. And well, I need a model variable, which will be my actual function with the arguments passed in. Okay. And now I want if I'm going to have accuracy, precision, recall, and F1, I need not only the real results, my Y test, but I also need my Y predictions. So let's make some predictions. Y pred is equal to my model dot predict. And I want to predict on my X test. For precision, recall, and F1, I need to specify a average because these are not binary. It is not a binary feature for the prediction class. It's a multivariable, so I'm going to specify my average to be a macro because I want to be as punishing on my algorithm as possible. And then I'm also going to be rounding, so I'll say places is equal to 4 for my rounding. And well, let's print out the score. So we'll say accuracy score. And actually, before we do that, let's say np.round. And I want to round an accuracy score. I want my Y true, so that'll be my Y test. And then my Y predictions. And I'm going to round that to the 4 decimal places. And I can do the same for my precision, recall, and F1 scores. So I'm just going to do that real quick. Precision score. Oh, not predict. Precision score. y test, y predictions. I need to specify my average, and that will be equal to my average, which I've already specified as macro. And for precision, I need to specify a 0 division score. I'm going to specify it as 0. If I do not have any true positives or false positives, I want that to not count favorably for the precision score. I want that to be 0. So 0 would be unfavorable for me and for the model, and 1 would be favorable for the model. And then I want to round that to 4 places. And I'm going to do that for the same. So I'm just going to copy paste this for the recall in F1. And recall and F1 do not take 0 division parameters, but they do take an average parameter. And since this is a wrapper, I need to return, I want to return the model, because the train model is what I want. So I want to return that model. And then because it is an inner function, I need to return inner. Okay, that looks correct. Let's go ahead and decorate the train model with basic stat classifier. And down here, we're going to add the train model to the dummy classifier. And I need to pass in 4 more parameters. So this one will be xtrain, ytrain, xtest, and ytest. Okay, and let's save that and take a look just to make sure I'm on the right track. So Python, let's clear that and then run shuttle.py. Editor tool from editor tools. That's interesting. Okay. Okay, so my decorator is working, and I get an accuracy for my dummy classifier 79.61, and then precision, recall, and F1 score of 11, 14, and 12% respectively, which is horrible. So we're going to try and fix that. Let's go on to make some other models. The other models I'm going to work on here are a random forest classifier. I'm going to also create a multi-layer perceptron. And I'm going to try a k-nearest neighbors classifier. For my random forest classifier, I will call train model, pass it in an instance. Random forest classifiers do depend on a random state to be reproducible, so I will specify that. And they also specify the number of cores you would like, as they can be spread out across multiple cores. So to do that, we'll specify n jobs. And I'll set that equal to cores. And of course, random forest classifiers perform well on unstandardized or unnormalized or standardized data, so there's no need to pursue that. However, for multi-layer perceptrons and k-nearest neighbors classifiers, we actually need to specify a standardizer or a normalizer, or whichever algorithm you like. I'm going to choose a standard scaler to scale the data. So I'll call ss.standard scaler. I'll go ahead and fit that on my training data. And then I will use that training data to specify a scaled xtrain and a scaled xtest. So that will be equal to ss.transform xtrain, and then ss.transform xtest. And my multi-layer perceptron model will be equal to train model. Multi-layer perceptron classifier. Need to specify a random state to be reproducible. And then instead of xtrain and xtest, I want xtrain scaled and my ytrain, xtest scaled, and my ytest. And something similar for my k nearest neighbors classifier. So KNN model is equal to train model, k nearest neighbors classifier. This one doesn't take a random state, but we can spread it across multiple cores, so I will do that. And much like the perceptron, we need to pass scaled or scaled data to the k nearest neighbors classifier. Okay, and let's reset the REPL, and let's run it one last time. Okay, so right off the bat, it looks like random forest is looking pretty good. Multi-layer perceptron and k nearest classifier will take a little bit of time, so just waiting on that. Oh, the perceptron is done, and the KNN is done. So looking at this, they all pretty much get 99% accuracy, or all three of them. For the precision, it looks like the perceptron and the random forest does a little bit better. And for precision and my F1 score, the random forest also performs better than my perceptron. So that's what I'm going to choose for my model. I'm going to, in the REPL itself, I'm going to import pickle, and then with pickle, I just call the shuttle model .pickle. I'm going to write a binary file as pickle file, pickle.dump. I need to pass in an object, so random forest classifier model, and my path will be pickle file. And I should have a shuttle model right there. And that does it for part one. So just to recap, I specified the number of cores and tried out a dummy model first and foremost. I built a training model that fits an xtrain and ytrain. I built a wrapper function to print out some of the basic classifier scores that I might want to try out. I then built 4 models, one being a dummy model, and then a random forest classifier, a multi-layer perceptron, neural net, and a k nearest neighbor classifier. Turns out the random forest performs the best out of those 3 without any hyperparameter tuning. I'm not going to hyperparameter tune this model. The random forest classifier works well enough. And I then saved my model as a pickle file. So the next part will be part 2. I will be building a GUI application with tkinter, so look out for that video. Until then, hope you watched this to the ending. If you did, thank you for watching, and I hope you got something out of it.